Good afternoon, everyone, and a very warm welcome to our April edition of our Office for Digital Innovation, Blockchain and Innovation Circle. I know it's quite a mouthful. I am delighted to have Pierre Samaties here with me from the DFINITY Foundation, and he will be introducing us to the Internet Computing Protocol, or ICP. Just generally speaking, most of you know this Blockchain Innovation Circle is intended to explore emerging technologies, their implications, of course, for financial market infrastructures and the broader innovation landscape in Liechtenstein and beyond. And also, we are very much driven by taking a concrete look at emerging developments and applications, so concrete use cases and developments. In that spirit, today's session will give us a chance to look at a very different approach to decentralized infrastructure, one that certainly raises interesting questions around architecture, regulation, and long-term scalability, and where these developments are headed. So what can you expect from this session? We have structured it in 3 themes. So after a short intro by Pierre, we will look into ICP as a technology and what DFINITY is doing there, and how the technology differentiates from other decentralized infrastructures and centralized infrastructures. Then in the second part, we'll take a look at very concrete use cases and how that comes to life. And finally, we'll have a brief outlook on how this might evolve further, of course, especially including potential intersection with AI. So Pierre will take us through these topics, and there will be time for discussions and questions. As always, feel free to drop the questions or remarks in the Q&A section. You can also raise your hand, and as always, also, the session is being recorded, and we will make it available on our Impulse-Liechtenstein video blog site shortly. Okay, I think with that, we can dive right into, and before concentrating on the content, another welcome to Pierre. Thank you very much for joining us. And I would invite you to introduce yourself and give a short intro into your professional background, as well as your main current professional field of activity within the DFINITY Foundation. The floor is yours. Thank you, Pierre.
All right. Thank you, Clara. And welcome to everyone joining. So I have the pleasure to talk to you today about something that's really exciting in my view, which is basically a new approach to digital sovereignty. We're going to talk about sovereign clouds and self-writing apps. But before that, quick intro from my end. So my name is Pierre Samaties, Chief Business Officer at the DFINITY Foundation. I'm involved in blockchain since end of 2014. So it's nearly been 10 years now. Time moves really fast. Have a long career in management consulting, been a partner at Roland Berger, and also founded and led the digital asset and Web3 practice at Roland Berger. Before that, worked for a long time in the energy sector, which also is what got me into blockchain initially. And I'm living since 11 years in the Middle East, and hence worked on many assignments for the Abu Dhabi Sovereign Fund and the Dubai government. Been a board member, an investor in many tech startups, always at the intersection between digital assets and AI. And just from an academic background point of view, I actually started my career in IT. So I did a bachelor in IT and then did an MBA on top to go into the business side of things. At the DFINITY Foundation, I'm taking care about business strategy execution, running all kind of commercial activities, strategic partnerships, and special projects. So having said that, as mentioned, I would love to talk to you today about 3 things. And I have a quick summary at the end for those that might join a bit later. So first of all, I would love to talk to you about DFINITY. What is DFINITY and what is ICP, the Internet Computer Protocol? In the second part of the presentation, we're going to talk about sovereign cloud and sovereign apps. And in the third part of the presentation, we're going to talk about what is probably the most exciting development that's happening in the space right now, which is the self-writing internet paradigm. So DFINITY is the foundation. It's a non-profit organization based in Zurich. It is the foundation that is the main contributor to the Internet Computer Protocol. The Internet Computer Protocol by now has been developed on the back of 1,000+ person years of R&D effort, so significant R&D effort that went into the technology. Hence, also, we have been repeatedly called the NASA for decentralized web technology, given the very scientific and first principle approach to the design of the technology. Roughly 250 team members in the US, Europe, Asia, and the Middle East. As mentioned, headquarters in Zurich, Switzerland, and a few weeks ago, we just opened our US headquarters in San Francisco, where in particular our AI team sits. DFINITY and the Internet Computer Protocol is founded by Dominic Williams, who is also the chief scientist and president of the foundation. And as you can see from the logos on the page, most of the employees that work for DFINITY have a background in either cryptography and/or big tech companies, with a lot of academic citations, patents, and so on. So, why do we need the largest R&D team in Web3? Because the vision of the internet computer is very bold. It is basically making a decentralized world computer. And you might have heard the term world computer beforehand from other blockchains, but I will explain to you in a few minutes on why world computer here literally means world computer and not just world calculator. So the technology has a significant market potential, and we continue building it even further. So what is a world computer? It is actually an environment where you can run any software that will be immune to cyber attacks and free from foreign control. And the Internet Computer Protocol has many different technical facets given by the amount of R&D that you've seen, but maybe just to highlight two of them that are important to underline the statement. So number one is there is physical decentralization. So the ICP network runs on 1,500 independent nodes across the entire world, which means if one part of the network goes down, God forbid, let's say one part of the world has an outage or something, the network would still be running and you would still have access to the apps that you run on the internet computer because compute is replicated. Second is, given that we use blockchain security for the entire software stack, anything that runs on the internet computer is immune to cyber attacks. So a very strong vision and a very strong purpose, namely to create a better compute environment for all of our software. Now, how is that possible, you might ask? Because what you normally think about when you hear blockchain is a token ledger, right? So how can you store compute on a token ledger where hardly you can even store a phone photo these days on different blockchains? Well, what I would love to achieve in this presentation is that for sure there should be one takeaway, which is think about blockchain from a different point of view. Don't think about it as blockchain is just a token ledger. Because if you want to have a true world computer, then you cannot just decentralize the token ledger, you need to decentralize the entire compute. And this is what DFINITY has been going out for with the Internet Computer Protocol. So we have developed a world computer where blockchain is a sovereign compute layer. And just to illustrate that, so what you see on the left side is usually what you understand when you hear in mainstream something is built on blockchain, let's say on Solana or Ethereum or Cardano or any other of the 11,000 projects on CoinMarketCap. Then what is really on the blockchain is the token ledger. All of the rest of your compute stack, the front end, the APIs, the middleware, the complex backend operations and data storage are usually on centralized services like Amazon Web Service, Google Cloud, or on a few decentral kind of patch pieces like internet, like IPFS, for instance, and so on. So what ICP has done is we took the entire compute stack and put it onto a decentral infrastructure that is safeguarded by blockchain security. So apps that are running on the Internet Computer Protocol end-to-end run on a blockchain infrastructure, run on a decentral tech infrastructure. And here's just something for the vocabulary later. We call this entire stack canister. So a canister on the Internet Computer runs an entire application. So it has the capabilities or the security aspects of a smart contract, but it runs the entire compute stack. Now, ICP math and the replication of the compute basically make the software immune to cyber attacks. So cybersecurity systems are necessary because everything runs in a virtual execution environment and it's safeguarded by a mathematical network protocol, which means that even if, let's say, a few of the nodes that would be running the Internet Computer would turn malicious, due to the replication and due to the virtual execution environment and the Byzantine fault tolerant protocol, you will not be able to break the software, break the network, or corrupt any computation that happens. So this is a very, very important thing to understand because compute can be made very secure through the power of a mathematical network protocol like this. There are a couple of other features that we embedded in the Internet Computer Protocol, and I don't want to bore you with too many technical elements, so I'll just give you kind of a rundown on kind of the main design elements that are important for you to know as well. So first of all, we have a reverse gas fee, because it was very clear from the beginning that when the protocol was designed that you cannot have a gas fee where you put the burden on the users to always top up a bit amount of money if you want to do a transaction. So the way gas works on the Internet Computer is if you are a developer, like in the Web 2 world where you would pay Amazon Web Services, you would pay the network in ICP tokens for compute cycles. And then it's up to you to monetize towards your user. That is the only scalable approach for compute in our point of view. Second is it's ultra-fast transactions. ICP is the fastest blockchain. You can verify that on ChainSpect, which is an independent ranking. It has a theoretical throughput of 200 transactions per second and a finality of 1 second. So it is lightning fast, which is also what is needed for compute, but also for any financial use case that you would go after. We also have a decentralized digital identity, which is a passkey-based digital identity. So you can use your phone or let's say your Face ID or your fingerprint or whatever you want to safeguard your digital identity. It's called Internet Identity, and it's basically the key to access any app on the Internet Computer Protocol. It has an online governance system. So the Internet Computer itself is the largest DAO in existence in the world today. Any application that runs on the Internet Computer can be turned into a DAO, and that means it can be community-owned, user-owned, or even if you think this a bit further, it can be AI agent-owned as well. And the final important aspect to know as well is interoperability. So the Internet Computer has a protocol level integration with Bitcoin, with Ethereum, and soon with Solana in 2 weeks from now, which allows anyone that builds on the Internet Computer to read and write on these chains. This is why, for instance, a lot of Bitcoin DeFi and Bitcoin Web3 projects are currently built with ICP technology in the background. That also means that anyone that has already built on Ethereum or built on Solana, they don't need to switch their ecosystem. They can just make use of the rest of the compute stack on the Internet Computer. So it's a really complementary technology as well.
Pierre, I may just quickly jump into here. How does this protocol withstand, or would it withstand quantum computing capabilities or quantum level decryption capabilities, so to speak?
Yeah, we don't have a specific quantum encryption yet, but obviously we looked into this, and that would be very easy to kind of upgrade that. We think though quantum is still a while out. So I won't say it's like the year 2000 problem where everyone thinks it's going to be a big deal. It is for sure going to be a big deal, but I think we'll probably have a few decades until this really becomes an issue. But we can update this system. Yeah.
Okay, thank you.
Yeah. All right. So now going into sovereign cloud and sovereign apps. So digital sovereignty now more than ever is a matter of national resilience by now. So the situation today is the following. Most of the world's mission critical data still sits on cloud that is controlled by foreign jurisdictions, really taking away true digital sovereignty, not only for states of enterprise, but also for individuals. Depending on what statistic you look at, you find that 90+% of all cloud data is processed on US, Chinese, or foreign cloud providers. And in addition, last year, the world has spent $9 trillion on cybersecurity. Now, this is a problem, or this causes a couple of problems. Number one is if you run if you run your operations or your data on foreign clouds, and even if it's on-prem cloud, but the provider is a foreign entity, then usually they need to obey to their intelligence laws that will override any kind of local jurisdiction. So you really put your sovereignty at risk. Second is, I think now also more than ever, we see something that has been kind of around for a long time, but it's now really in the limelight, which is tech nationalism, right? So tariff wars and sanctions are no longer hypothetical, and you already see many European countries, but also the parliament are increasingly looking into efforts to de-risk that exposure that they have. Last problem is you have a single point of failure. Multi-hour outages on hyperscalers are unfortunately becoming the routine, and insider attacks and front-end hacks as well. Let's just look at some of the news, and you can literally pick any day, but there's no day going by without, or at least a week going by without some major hack or some major outages. And all of these things have one thing in common. They point to a single point of failure because either something is run on a centralized network, or in the case of crypto or blockchain, for instance, it exposes to a certain extent to a certain extent, fake decentralization that you have. Because yes, your token ledger is on chain, it's decentralized, but if your front end still is on Amazon Web Services, you expose yourself to just your regular hacker that can just break into Amazon Web Services, change your front end, and there we go. One prominent example that we've seen in the past weeks, unfortunately, was the Bybit hack, where the Safe Wallet had a hack of the front end, right? So people were made to believe that they see something or they execute something which they haven't executed, and that is exactly what we're trying to fix. So the solution for this problem is twofold. Number one, if you want to build on a public network, you can use the Internet Computer Protocol. But also we are fully aware that for some governments and enterprises, you want to have control over your own hardware. So there is a second option, which is called Utopia, where you basically can take the Internet Computer technology and, if you want to say so, create kind of an intranet version for yourself, which runs on your own sovereign hardware. That would have kind of the same benefits as running on the Internet Computer Protocol, with the additional benefit of you controlling the hardware, and you can have a truly national sovereign setup. You could run this on your own data centers, but you could also spin it up on top of big tech. So you could also, let's say, spin up a Utopia instance on top of one leg on Amazon Web Services, one leg on Alibaba, one leg on Google Cloud. But it gives you the additional benefits of cybersecurity. Utopia can also be deployed in field environments. Obviously, also a very, very important relevant security aspect that if field operations are happening, the last thing you want to have is a risk that the network gets hacked or something is frauded. Two examples of applications on mainnet that are live. So by the way, there are over 500 projects live on the Internet Computer. So I'm just giving you kind of two examples for you to check out if you're interested. So Oisi.com is a 100% decentralized wallet, and it's the only wallet out there in existence that's truly decentralized, which means front end, back end, and everything is decentral, which means it cannot be hacked. Yeah, so these kind of front end exploits that you've seen with other wallets are not possible. And unfortunately, also digital asset wallets have become obviously a very big target for hackers as well. With something like Oisi, they would stand no chance, given that everything is decentralized. Everything can be accessed through the browser. That's also an important element. Any application on the Internet Computer can be accessed just normally through the browser, like you would access any web application. It is a multi-chain wallet, so it holds Bitcoin, Ethereum, Solana, ICP, even Swiss Gold by now is in Oisi, so I encourage you to check it out. Second example of an application running on the Internet Computer is OpenChat, www.oc.app, which is basically a full Telegram plus WhatsApp plus WeChat, but 100% sovereign. It has over 230,000 users, and your chat is really your data. So if you would delete yourself, all of your data will be gone from this system. No one can basically exploit your chat data. And this project has been running since 3 years without any hacks, without interruption. And as you can see, 235,000 users is also quite a testament to the performance of the system. All right, then a final thing I would want to talk about is the thing we're currently most excited about, which is what we call the future is self-writing. And maybe you have seen a few of the presentations by Dominic, our founder, who has been talking about it on main stages for the past 2 to 3 months. What is it about? So first of all, if you look at today's world, then already 25% of all new code is written by AI. This is a trend called vibe coding. Yeah, you can really do the test if you walk into a room of developers and ask them like who is using AI-assisted coding tools. 99% of the hands will go up. But we believe this will evolve into something way bigger. It will evolve into a self-writing paradigm where AI writes 100% of the code and orchestrates the applications end to end. So what it means is anyone can chat to create. So anyone on this planet will be empowered to create, deploy, and update apps by just chatting with AI. And that doesn't matter if you're an individual that just wants to, do a quick site or app to share with friends. Whether you are a startup that can now start with less because now all of a sudden you don't need to spend all that money on development. Or you're an enterprise that wants to get out of, or a government that wants to get out of the lock-in of vendors and tech debt, and you just want to create your own applications and being able to fully control them and update them on your own. Sounds like the future, but we're actually very close. So what is gonna, if you follow the Internet Computer, you might be aware of this. But what we're going to release very soon is the alpha access to a tool that is currently being built called caffeine.ai, where you will exactly be able to do that. You will have a ChatGPT kind of interface that obviously by now every one of us knows from our daily interactions with AI. You can just prompt whatever application you want to have, whether it's a CRM system or a blog or whatever you want. And then not only will the code be returned to you, but you are getting a URL back today in a matter of like 2 to 3 minutes with the application live and deployed on the Internet Computer. So it's live and you can share it, you can use it. Not only that, you can actually update the application in production through prompting. So let's say you created a CRM system, you already added like 100 fields or 100 lines in there, and then you say, oh, I actually should add another field for, I don't know, a specific campaign. What would happen in the Web 2 version of this is you would lose all the data. As soon as AI updates this on Web 2, it will lose the data. On the internet computer, because of its very specific components, it will not lose the data. So you can update the applications while they're in production. This is, in my view, I've said in the beginning, I'm in this space now since nearly 10 years or a bit more than 10 years. This for me is the single biggest innovation that blockchain actually has born since the invention of Bitcoin and smart contracts. So finally, this is a use case where a blockchain infrastructure is naturally better than a Web 2 infrastructure. And AI, obviously, in the future, if we believe in a future where AI is going to build more and more on their own even, then you can be sure that AI will choose the infrastructure that they want to build and orchestrate apps on. And it will not be traditional IT. So we believe that the internet computer is the only infrastructure where I can actually build solo. And that is in particular because there are three key advantages for AI. Number one, and if you now remember what I showed you in the very beginning of this full stack compute that we call canister, number one is the deployment is absolutely seamless, which means an AI can just deploy the entire thing in a canister, right, in one place, instead of needing the need for the complexity of managing the current IT stack, database, front end, cybersecurity, all different providers, and so on. Second advantage for AI is what I mentioned with the no loss of data on updates. So ICP has a proprietary coding language called Motoko. Again, don't want to be too technical, but I think it's an interesting, super interesting thing to understand is we have something called enhanced orthogonal persistence, which basically means data and logic are the same. So the data sticks to the code. So whenever you update an application, you don't lose data. And that is super relevant for AI because then AI can actually update applications nearly live without any issues. Last advantage for AI is the aspect of being immune to cyber attacks. A security risk in AI coding is a hallucination away, right? Because you run the risk in a Web 2 infrastructure of creating security holes that can be exploited between these different layers of IT. While given the fact that everything on the internet computer runs in a virtual execution environment and not on silicon, you have eliminated this risk. So it's going to be a significant paradigm shift where creating software is probably going to be just 1% of the cost, maybe even less. We don't know. Yeah, we will see. And however, it's development by 100x. Yeah. All right, then to summarize my points, number one is the internet computer is the only true world computer in existence today that is really capable of running full decentralized compute stack. Second takeaway is anything you deploy, whether it's on ICP or on Utopia, is a truly sovereign application and eliminates your reliance on centralized big tech. Third takeaway is that if you're a government or you're an enterprise, you can also deploy a Utopia instance, a Utopia cloud instance to regain your digital sovereignty. Fourth takeaway is the future is about self-writing apps. And number five is that we strongly believe, also by the way that we're going to see with Caffeine, is that the internet computer is the only platform where AI can build solo in a seamless and efficient and secure way. And with that, that's the end of my presentation. So happy to discuss.
Wow, perfect. Thank you, Pierre. That's fascinating. Well, we already have one question in the chat. It's from Glenn Cameron from Bonded. He's asking whether you can run data between Utopia and ICP with anonymity, so that there can be a share of data between government, internet, and an enterprise use case on ICP itself.
Yeah, that's going to be possible. That's what the engineers are working on as well. So by the way, actually, it's a very good question because I haven't mentioned that. So whenever you run a Utopia instance, it doesn't mean that you're isolated. You can actually always connect to mainnet. Yeah.
Okay, interesting. The other thing with regards to the use cases, the applications that you mentioned before, what do you think? How mature are these applications in terms of user adoption? I mean, do you see engagement also from traditional industries and or mostly from the crypto native space?
Yeah, that's a good one. So on the two applications that I showed you, like Oisi and OpenChat, so far they have been mainly engaging with the Web3 audience. OpenChat has now 235,000 signed up users. Oisi launched 4 weeks ago and has now around 15 to 20,000 new wallets. But I think that's in general, I think the key point for the entire industry. I think Web3 really needs to break out of that Web3 bubble. Yeah, because if you look at the user base, then depending on which statistic you look at, but crypto.com, I think they just published that we have around 600 million crypto users, or at least buyers of crypto, right? But if you look at the developer numbers, then the developer numbers to a certain extent are pretty much stagnant. I think the overall pool of Web3 developers is still only around, like, give or take 30,000, right? That's why also we're so excited about the self-writing internet and Caffeine, because finally you can give it into the hands of everyone and you don't need to tell anyone, hey, this is Web3, try it out. No, they're gonna try it out because it's just a great experience to create your own apps.
But when you mentioned developers, what is there, from developer perspective, what is their experience compared to more established chains like Ethereum, for example, or Solana?
Oh, what I mean with these 30,000 is the total developers we have in the entire space, right? Across all the chains. So developing on the instant computer is pretty straightforward. And it's gonna be even more straightforward with Caffeine AI, because then even if you're a developer, you can just create something and you can take the code and then craft it on your own. You can code in Rust on the internet computer if you want, which is a pretty well-known language. But you could also use an EVM. So you can also, if you build something on Solidity, you can just move over. Or what I mentioned with this chain fusion, where we have this protocol level integration with these different chains, you can also just completely stay in your ecosystem and use the rest of the stack on the internet computer.
Do you see any? You mentioned the whole AI and self-writing. Do you see any limitations in terms of performance or cost with these developments?
No, not at all. Because I think if any, it actually like cuts the cost by 99% down, right? If you look at the entire development life cycle. And again, just to give you some idea, if you want to run a social network with, let's say, 2,000 people, 2,000 users per year on the internet computer, it will cost you probably at around $900 of computing costs per year.
I see.
Which is really nothing, right?
But when speaking about AI writing itself and build solo, what kind of safeguards and oversight mechanism would be needed for such a decentralized AI system and development?
Yeah, so there are a couple of things. By the way, I haven't mentioned it in this presentation, but given that we have this full stack compute, you can actually also run AI agents in these canisters fully on chain, right? So you can have your own privacy preserving AI agents. On the self-writing part, the way to safeguard it is number one, obviously, you would still own, as a user, you will own the canister, so you can turn it on and off whenever you want. The second thing is our engineers are working pretty hard on putting rails around the different models that are involved in caffeine. So to ensure that the code is correct on the back end, but also the front end is properly managed. So the different AI models at play at the moment.
I see, understand. Okay, great. Well, are there any further questions from our audience? I think so far not, because then I would say we don't need to drag these on and out for too long. And I would like to thank you, Pierre, for your time and these interesting insights that you shared with us, and to the audience for your participation. If anyone is still interested in exploring this further, I believe Pierre will be happy for them to reach out directly, or you can always direct your questions, of course, also to us at the Office for Digital Innovation. And having said that, I just want to give you the next date as a save the date for the next Blockchain Innovation Circle. That will be on the 20th of May, and the topic will be soon announced as well. And yeah, I would say with that, Pierre, thank you very much again for these insights and this presentation. And I will be seeing you soon.
Yeah. All right. Thanks for having me. See you soon.
Thank you.
Bye.